Hello. Today we will discuss heat intrusion, conduction, convection, and radiation. First, here is the table of contents. The types of heat transfer include conduction, convection, and radiation. In a superconducting magnet, we need to prevent heat from entering from the outside, so we refer to it as heat intrusion. Now, let me explain the concepts of conduction, convection, and radiation. First, conduction is the transfer of heat through direct contact between particles within a substance. Due to the random motion of atoms and molecules within the substance, the kinetic energy of particles moves from areas of higher temperature to areas of lower temperature. An example of this is heat moving from the flame to your hand through a metal rod, as shown in the illustration on the right. Second, convection is the transfer of heat through the movement of fluids, such as liquids or gases. This occurs due to differences in temperature within the fluid, which create differences in density, causing the fluid to move. An example is hot air rising from a flame and warming your hand, as illustrated on the right. Lastly, radiation is the transfer of heat through electromagnetic waves. Unlike conduction and convection, radiation does not require any intervening medium. An example of radiation is the heat from the sun, and another example is the heat from a flame being transferred to your hand through electromagnetic waves, as shown in the illustration on the right. Thus, heat is transferred through three methods: conduction, convection, and radiation. Next, I will explain where conduction, convection, and radiation, or heat intrusion, occur in a superconducting magnet. The illustration below schematically represents the cooling system of a superconducting magnet. At the center, the superconducting magnet is fixed through a support, and a current lead connects the magnet to the outside. The superconducting magnet is immersed in liquid helium for cooling, and the exterior of the system is surrounded by liquid nitrogen within the outer wall. The space within the outer wall, except for the liquid nitrogen, is a vacuum. Above the liquid helium, multiple layers of radiation shields are installed. Through the animation, I will explain the heat intrusion within the superconducting magnet. In this system, conduction occurs through the support and current lead, which are directly connected to the magnet. Convection occurs in the liquid helium in which the magnet is immersed, transferring heat to the magnet through fluid movement. Lastly, radiation transfers heat without an intervening medium, allowing heat to enter the magnet from all directions, as shown in the illustration. Temperature is the most important factor in maintaining superconductivity. Therefore, when designing a superconducting magnet, it is crucial to consider heat intrusion from conduction, convection, and radiation. To summarize, conduction is the transfer of heat through direct contact between particles of matter. Convection is the transfer of heat through the movement of fluids, like liquids or gases. Radiation is the transfer of heat through electromagnetic waves. In superconducting magnets, heat intrusion is a big deal. So, it's important to calculate the conduction, convection, and radiation happening within the magnet. This concludes my presentation on heat intrusion, conduction, convection, and radiation. Thank you for watching.